massive event in the universe shaking the stars? The Nanograv Observatory detected it coming from supermassive black holes billions of times larger than the Sun, possibly revealing the nature of the universe. Astronomers have for the first time detected giant ripples in the spacetime field. These gravitational waves of such magnitude are believed to come from merging supermassive black holes. Each black hole is billions of times larger than the Sun. By studying time fluctuations in radio bursts from rotating pulsars, called pulsars, the team of scientists from the North American Nanoverse Observatory for Gravitational Waves, also known as Nanograv, can capture neutron gravitational wave. Future research on them may reveal clues about the first moments after the Big Bang, hoping to uncover mysteries such as the nature of dark matter, which makes up most of the matter in the universe. When any object with mass accelerates, it creates distortions in the space-time field, called gravitational waves moving at the speed of light. It stretches and compresses the space-time field along its path. Gravitational waves were predicted by Albert Einstein in 1916, and scientists discovered the first evidence of gravitational wave with the Laser Interferometer Gravitational Wave Observatory (LIGO) in 2015. Just as light has various wavelengths and frequencies, from gamma rays with high frequency and short wavelength, to radio waves with low frequency and long wavelength, so do gravitational waves. LIGO detects gravitational waves with much higher frequency than Nanograv's detection. Currently, the Nanograv research team has found low-frequency gravitational waves with wavelengths so long that light takes years or decades to travel between their peaks. To detect these giant ripples, scientists need to assemble sensors larger than Earth. Over the past 15 years, Nanograv has analyzed 10 stars in the Milky Way. To create a galaxy-sized gravitational wave detector, they focus on millisecond pulsars, born when massive stars die in supernova explosions, leaving behind rapidly spinning neutron stars or pulsars. The extremely dense stellar remnant emits dual radio beams from its magnetic poles, flashing like a lighthouse. Each time a beam sweeps past Earth, radio telescopes detect a pulse. Hundreds of radio pulses occur per second with extreme precision. The team monitors 68 pulsars located within a few thousand light-years from Earth. Because gravitational waves cause the space-time field to stretch, and they alter the timing between radio pulses, causing some pulses to slow down, while others speed up in a distinct, predictable pattern. This fluctuation is also observed in pulsar pairs, following a model dependent on the distance between the two stars. This proves that gravitational waves affect both stars. Pulsars produce very weak radio sources. Therefore, to conduct this research, scientists spend thousands of hours per year observing with the world's largest radio telescopes, including the Arecibo Observatory in Puerto Rico, the Green Bank Observatory in West Virginia, and the Very Large Array Cluster in New Mexico. Thanks to this, it can detect the timing of radio pulses within 1/1,000,000th of a second. The most likely source of the newly detected radio waves is pairs of supermassive black holes 100 million to 10 billion times larger than the Sun. In contrast, the gravitational waves detected by LIGO come from collisions of smaller black holes, or neutron stars with masses only a few times that of the Sun. Astronomers believe that supermassive black holes lie at the centers of the largest galaxies in the universe. And when two galaxies merge, the black holes at their centers move into a new galaxy, forming a binary system and generating gravitational waves as the two supermassive black holes slowly. Although the signal has not yet fully met the gold standard for detection set by the scientific community, but astronomers are confident that their results provide compelling evidence that the gravitational wave background can be generated by the merger of two supermassive black holes. Another possibility is that intense physical processes after the Big Bang could also contribute to creating a gravitational wave background. As teams combine data and continue observing, they will study in more detail the nature of massive black hole pairs and even, possibly, anomalous physics in the early universe. A giant planet has just appeared unexpectedly. A giant planet named Hala has just surprisingly appeared around the star radiation, which had just flared out into a red giant star and should have swallowed this planet. It is a Jupiter-like giant planet called Hala, discovered when scientists observed the radiation phase slowly into a red giant star. Stars in the universe like our Sun, when running out of energy, will flare out one last time into a red giant. Then it will collapse into a small white dwarf. During the final flare-up,
stars can swallow some nearby planets.
The Sun has been able to swallow the 3 closest planets, Mercury, Venus, and even Earth. However, around the radiation, scientists from the Institute for Astronomy at the University of
Saw Hala appear right after the red giant star's outburst peaked,
and began to shrink into space that radiation had previously occupied at its maximum size. The latest observations confirm the planet has been orbiting stably for over a decade, and it truly coexists with this parent star that is trying to swallow it. Scientists still don't fully understand why Hala survived. One possibility is that it was orbiting at a farther distance before the red giant star's
then moved inward, but that likelihood is very low.
A second possibility is that Hala formed from the collision of 2 stars,
creating a gas cloud from which Hala formed.
Thus, Hala could be the legacy of one of the 2 dead stars rather than the radiation. Or simply, it truly survived the red giant catastrophe.
And that might bring a little hope for Earth's future.
Monster black hole near Earth awakens amidst threatening signal. The monster thought to be sleeping peacefully in a galaxy contained has unexpectedly revealed a frightening signal, recorded by NASA's IXPE spacecraft. These are echoes from the realm of death,
living proof that the monster of the Milky Way is not completely asleep as once thought.
Sagittarius A is the black hole at the center of the Milky Way galaxy containing Earth. Has passed its period of frenzied feeding. It has an estimated mass of about 4.1 million tons, and belongs to the group of supermassive black holes that astronomers often call monster black holes.
But increasing evidence shows that this monster still quietly awakens
and eats unfortunate living beings near its mouth. Fortunately, the IXPE spacecraft recorded the unusual brightening of molecular clouds forming giant stars residing near the heart of this monster and realized they are shining brighter than expected in X-ray light. Analyses indicate this X-ray is not emitted by the clouds themselves,
but is reflected by light from an outburst of this monster.
Calculations by scientists from the University of Strasbourg, France, show this outburst occurred only around the 19th century, thanks to complex reflection events that we can observe through a mirror with a fairly low delay. In reality, though considered asleep, Sagittarius A** still possesses a strong gravitational field around, enough to tear apart any unfortunate object flying too close with it.
This time the black hole's meal lasted a year and a half, a long time for humans.
But in the lifespan of celestial bodies, it's just like a blink of an eye.
Please subscribe to the GI and MI Go channel so you don't miss out on exciting videos.